Hello, welcome back. Today we're going to be talking about writing algebraic expressions from verbal models. The objective is that by the end of this video, you should be able to write algebraic expressions from verbal phrases. The first thing we're going to do is we're going to identify some math words and their operations. The word operation meaning add, subtract, multiply, and divide. The first ones we're going to look at are words that mean to add. Adding words are words such as sum, plus, more than, or increased by. Those are just some examples. There are a few more, but let's take a look at this. Suppose you're asked to write the sum of a number and 5. When given the words a number, that means you don't know what that number is, which means it's going to be represented as a variable or letter. Since they say the words a number, we can call it x or we call it n. So we're going to be summing a number n and 5. Well, that means you're just going to be adding n plus 5. We sum them up by adding them together. What about 3 more than a number? Well, a number again, we're going to call it n, some variable, and we're going to be making it 3 more than that number. So we take the number and we add 3. This is 3 more than n. What about a number increased by 9? Same story, we take a number and we increase it by 9. Now let's take a look at words that mean to subtract. Common subtraction words are difference, minus, less than, or decreased by. Let's take a look. The difference of a number and 5. Again, n representing any number, a variable, and we're going to take the difference of n and 5, meaning we take n minus 5. What about 3 less than a number? This one's a bit tricky because the order we say it and the order we write it are opposite from each other. In order to take 3 less than a number, we get a number and we subtract 3. A number decreased by 9. So again, we take a number and we decrease it by 9. Now we're going to look at words that mean to multiply. Common multiplication words include product, multiplied by, of, twice, and times. Let's take a look at a couple of examples. The product of a number and 5, n times 5. Half of a number. The word of means we take half, which is 1/2, and we multiply it by our number. Half of times a number. Twice a number. Again, 2 times a number. 5 times a number, well, it's 5 times a number. There's only 2 real common division words. Those are quotient and divided by. For the first one, a quotient of a number and 5. For this example, we would take the number n and divide by 5. Notice when they say a quotient of a number and 5, the first thing listed, the number, goes on top, and the second thing listed, the 5, goes on bottom. So the quotient of 2 and a number would be a different order, and that is very important. The quotient of 2 and a number would be 2 over n. 4 divided by a number, that would be 4 over n. A number divided by 4, that would be n divided by 4. Combination statements. These are a little bit more tricky because, again, the way they're stated, it said 4 less than twice a number. Well, 4 less than means we're going to take twice a number and subtract 4. 2n minus 4. Alright, here's a couple more combination statements for you to try out on your own. Go ahead and pause the video, work them out, and press play when you're ready to see the answer. Alright, the sum of half a number and 6. We take half a number and we sum it up with 6 plus 6. The quotient of, so we know we're going to divide. What 2 things? We're going to divide twice the number and 7. So we take twice the number and we divide it by 7. Now we're going to get into the bulk of what we're going to be doing for the rest of the video. And to do that, we need some basic terminology. The first one is the word verbal model. A verbal model are words and mathematical operations, addition, subtraction, multiplication, and division, written together to model a situation. So we're literally going to make a model with math from words. Let's look at an example. You work at a restaurant with 4 of your friends as waiters and waitresses. Your restaurant has a tip jar for all the wait staff. I need you to write a verbal model for the amount of money you will get from the jar. To do this, we really need to identify what's going on in the situation. So first, let's identify the information that's math related. You work at a restaurant, not so math related, with 4 of your friends. So you know there's 4 of you. May or may not be important. Your restaurant has a tip jar for all of the wait staff. Okay, that seems kind of important because that means all of you will be getting your tips from that jar. Write a verbal model for the amount of money you will get from the jar. Okay, so if there's 4 friends all together, and all of you are getting the money from just one jar, then the amount you should get would be the amount in the jar divided by 4, because you get 1/4 of the amount. So a verbal model would be the amount in the jar divided by 4. The last step in writing a mathematical model from a verbal model is we turn the words in the verbal model into math symbols. So again, our previous model had the amount in the jar divided by 4. In this example, the amount in the jar, I'm going to call that J as our variable. Or you could have called it A. And I'm going to take J and I'm going to divide it by 4. So I just got through writing a mathematical model that represents the amount of money you will get from the jar. You can think of writing expressions like putting a puzzle together. You're given the pieces of information that you need to put together with addition, subtraction, multiplication, and division. So one method of writing mathematical models would be to write down the math information given. We're going to collect all of our pieces that belong in our puzzle. Then we're going to write a verbal model from the information. So we're kind of putting our pieces together loosely. We're making the information add, subtract, multiply, or divide. The last step is we're going to write the mathematical model. We're going to put the pieces together in a way that fits the situation given. It's always good at the end, just like you would with a puzzle, to stand back from the problem and make sure it actually fits the situation, or that the puzzle actually looks like the picture it should. Also note that oftentimes you'll be asked to write an expression or algebraic expression for the given situation. The words algebraic expression or expression mean that you will write a mathematical model. Let's take a look at our first example. You're selling raffle tickets at $5 a piece to raise money for your favorite organization. You need to write an expression to represent the total amount of money you will raise from selling T raffle tickets. So you read the problem. The next step is to start identifying the puzzle pieces we need to put together, or the math information inside the statement. We look at it and we're selling raffle tickets at $5 a piece. Well, that's not kind of mathy, so we'll underline $5 a piece to raise money for your favorite organization. We're going to write an expression to represent the total amount of money. Well, that sounds kind of mathy, so I'm going to underline that as well. And you will raise for selling T raffle tickets. So, total amount from selling T raffle tickets. Anytime they give you a variable, it's a good idea to underline that information because it's probably going to be important in writing your expression. Okay, so now we need to start thinking about what it's asking us. The expression has to tell us the total amount of money. Okay, well, I'm earning money from selling raffle tickets. T of them. And they're $5 a piece. So, I know it's a $5 per raffle ticket, and I know I'm going to be selling T raffle tickets. Now all we need to do is figure out how the $5 and the T raffle tickets fit together in order to give us our total amount of money. Would we add $5 to the number of raffle tickets, multiply, subtract, or divide? Well, the answer is that we would multiply $5 times T raffle tickets, because that would give us the total amount of money from selling any number of raffle tickets. This is our verbal model. We can move it to a mathematical model or algebraic expression by doing $5 times T. We can go one step further because it's understood that the 5 stands for $5 by writing 5t. And now we've written an expression to represent the total amount of money we earn from selling T-raffle tickets. Alright, let's look at another example. This one's a little bit more complicated. You may choose to pause the video and work it out on your own, then see the answer. Or you may just want to listen to the explanation as we go along. Alright, we're going to mow some lawns to earn some money. And we know that it costs $50 for a lawnmower, and we're going to charge $30 a lawn. Our expression that we're going to write needs to give us the amount of money after expenses, that's going to be important, you make after mowing our lawns. So again, I'm going to underline the important math information, or just math information, period. We'll figure out what's important later on. I would underline, well, the first statement's not so important, because there's not really much math information there. But we do know that $50, there's a number there, so it's kind of mathy. Maybe we'll use that. And we're decided to charge $30 a lawn. Write an expression for the total amount of money after expenses you make after mowing our lawns. So it's $30 a lawn, $50 for the lawnmower, and we want the total amount of money. So how does the $50 for the mower and the $30 per lawn help us to identify the total money we get after expenses? Let's think about it. $30 a lawn. Are you earning that money or losing that money? The idea is that you're earning $30 a lawn, so that's a positive amount. $50 for the mower. Are you earning that money or losing that money? Well, the answer is you're losing that money. So that $50 for the mower has to be a negative amount. Now we just need to figure out how $30 a lawn translates into math. $30 a lawn. Well, $30 times the number of lawns minus $50 for the mower ought to give us the total amount of money we earn after expenses. Alright, we're on to our last example. I'd like you to go ahead and press pause, try to work out the example on your own, and then press play when you're ready to see the answer. Okay, so you've already read through the problem and you've underlined the mathy words. 30 rotations per second. Fan is turned off. The rate of rotation decreases at a constant rate of 6 rotations per second. T represents the time in seconds. And we're writing an expression that can be used to determine the number of seconds for the fan to come to a complete stop. So let's write down our information. 30 rotations, that's our beginning amount. And we're going to decrease by 6 rotations per second. So I can almost turn that into a verbal expression immediately because I know I'm going to be decreasing by 6 rotations per second. Alright, I use the dash to represent per second. So now we need to figure out where that t fits in. We've used our 30 rotations per second, we've used our 6 rotations per second, but where do we put the t? Does the t go with the 30, or does the t go with the 6? To think about that, we know t represents time. So if we put the t with the 30, that means 30t. It means every second, every t seconds, we're multiplying by 30. Does that fit the situation? Does that puzzle piece fit? Does every second, are we increasing by 30 rotations? Well, the answer is no. Every second we're decreasing by 6 rotations. So it'd be 30, standing for our initial amount, minus 6 rotations per second, 6t. So we start off with 30 and we decrease by 6 rotations every second. And now you've written a mathematical model or variable expression for this situation.